Hello everyone. So for today we are going to talk about comb sorting method. So comb sort method is mainly just an improvement over bubble sort. Comb sort improves on bubble sort by using gap size more than 1. The gap starts with a large value and shrinks by a factor of 1.3 in every iteration until it reaches the value of 1. Thus, comb sort removes more than 1 inversion counts with 1 swap and performs better than bubble sort.
So I will now explain how the comb sorting algorithm works. So first we have our given array. Then let your array length be n.
Okay, so for the first iteration, the gap will be equal to array length, which is n, over 1.3. So 6, because we have 6 numbers here, we're going to divide 6 to 1.3, which gives us a result of 4.6, which gives us the gap of 4. So for the first iteration, you have to start at the first element or at the first array index, then count to 4 because the gap is 4. So 1, 2, 3, 4, and then you swap those two numbers. Okay. So as you can see, I've swapped 1 and 4. For the next step, the initial will move 1 space forward. So it started with 1, the next is 5. So 5, count gap of 4, 1, 2, 3, 4, and then it will swap this number with 5. So after we swap, we end the first iteration because we reached the end of the array. So as you can see, I've swapped the numbers here, 3 and 5, because it had 4 gaps, 1, 2, 3, and 4. So for the second iteration, the gap earlier was 4. So we divide 4 by 1.3, and then the gap will be 3. So for the first step, we're going to look at the array and see if we need to swap the numbers. So for the first step, we do not need to swap because the first element is bigger than the second element, which means that the first element is already in place. So no need for swap. For the second step, we move forward to the next number and we count the gap number of 3. So 3 as our initial, then 1, 2, and 3. So 4. 4 is bigger than 3, so it means that we do not have to swap. So for our next step, we move forward one more time, and as you can see here, it reaches the end of the array index, which means this is the last step of this iteration. So we're going to swap 6 and 5 because 6 is bigger than 5, and 6 and 5 is... You're going to swap 6 and 5. And as you can see on the last part here, we have the end of our second iteration. So for our third iteration, the gap was 3. So we're going to divide 3 by 1.3. Then it becomes 2.3. So 2.3 is equal to 2. So our gap will be 2. So starting with the first index, then count 1 and 2. 1, 2. So our gap, as I said. So 1 and 5. So we don't have to swap these numbers because 5 is bigger than 1, which means 1 is already in place. So for the next step, like I said, 3 and 2. So we're going to swap 3 and 2 because 3 is bigger than 2. And as you can see here, the index 1 and 2 are already in place. So we're going to swap 5 and 4. 5 and 4 because 5 is greater than 4. So 4 is swapped with 5, and this is the last step for the iteration. It's the end of the iteration. You do not have to swap 3 and 6 because 6 is already in place. 6 and 5 and 6 is already in place. So for the fourth iteration, the gap was 2. So you have to divide it with 1.3. The answer will be 1.5. So our gap becomes 1. As said here, it will only stop until the value of n becomes 1 or below 1. So for the first step, we do not have to swap. For the second step, which is 2 and 4, we do not have to swap again. So for the third step is 4 and 3. You can see here, this is the final step of our swap, the last swap of our array. So, as you can see here, it's already sorted. 4 and 5. It's already sorted. So, we do not have to swap these numbers as well as here, 5 and 6. So, its output will be 1, 2, 3, 4, 5, and 6. So for the breakdown of the code's key elements, first is you have this get next gap function. So as you can see here, it is declared as an integer. So its purpose is to calculate the next gap size to use in the comb sort algorithm. And then for the shrink factor, it multiplies the current gap by 10 and then divides it to 13, resulting in a 0.77 gap to shrink it. And then for the minimum gap, it ensures the gap never becomes less than 1. So for the sorting function, which is the void sort, it implements the comb sort algorithm to sort an array of integers. So for its key steps, step 1 is the initialization of the gap, and then the gap is set to n. Int n is equal to the length of the array, and then this gap is set to n. So we set the initial gap to n, and then we set a boolean swapped flag to true to guarantee that there is at least one iteration. So the main loop, it continues while the gap is greater than 1, or it's not equal to 1, or is swapped in the previous iteration. And then it gets the next gap using the get next gap, and then it resets the boolean swap to false to track the swaps in the current iteration. And then it iterates through the array with the current gap using a for loop. Then it compares the elements. First is we set a temporary integer, and then it compares the elements at positions I and I plus gap, and then swaps them if they're in the wrong order, and then the boolean swap becomes true. For the main function, how the comb sort is demonstrated, first we create a comb sort object, and then we declared our array, our unsorted array, and then we printed out the unsorted array. And then after the for loop is we declare the object that sort function of the array, and then we printed out the sorted array. And for our output, we have our unsorted array, which is 4, 5, 6, 2, 1, 3. And then the sorted array, which is 1, 2, 3, 4, 5, and 6. That is all for the comb sorting method. I hope you understood my explanation.
Bye-bye.